this video, we're going to talk about distance in a space, distance between 2 points in a space, or distance between a point and the origin. Okay, let me start. I'm going to start by a recall. If you remember, in one variable calculus, we say that the distance from a point, for example xy, to the origin is what? If you remember, okay, let me graph it first. X-axis, y-axis, and the point, for example xy, to the origin. I'm talking about the length of this line. Okay, if you remember, it was x squared plus y squared and then square root, and then the distance between 2 points is this. If we have the 2 points x1, y1, and the point x2 and y2, then the distance would be the difference between the first coordinates square plus the difference between the second coordinates square under square root. Okay, now let's talk about distance in a space. I'm gonna ask you a question. What is the distance from the point, for example 1, 2, 3, to the origin in a space, right? So I'm gonna graph it first. So this is x-axis, I have y-axis, and I have z-axis. Okay, so assume the point is right there, the point 1, 2, and 3. Okay, let me have my box like this. To show the position of the point. Okay, when I'm talking about the distance, I'm talking about the length of this line in here. Okay, so how can I find this? You just notice that I have a right triangle in here. Okay, and in this right triangle, the length that I have here would be the height of my point, which would be 3. Okay, and how about this side? I know that this part would be, I know that this is 1, and then I know that this is 2, and I have a right triangle in here. So if I'm looking for this, it would be square root of 2 square plus 1 square. Therefore, in the first right triangle in here, I know this length and I know that length, so I get what? This would be square root of 3 square plus this side square, which would be 2 square plus 1 square. Okay, which would be 9 plus 4 plus 1, square root of 14. Okay, therefore I can say that the distance from a point to the origin, so I'm gonna say that the distance from a point, for example, ABC to the origin is equal to square root of a squared plus b squared plus c squared. I can have this box anywhere in a space to find the distance between 2 points, between 2 points in a space. For example, the point x1, y1, and then z1, and the point x2, y2, and then z2, with the same idea. Let me just quickly grab it for you. This is x-axis. I have y-axis, and I have z-axis. Okay, for example, if I have this point in here with x1, y1, and then z1, and okay, let me move this point exactly the same box. Okay, if this point is x1, y1, and z1, and for example, and for example, this point is x2, y2, and then z2, then the distance here would be with exactly the same idea. The length here and the length here. This length in here would be the difference between the height of these two, z2 minus z1, and this length in here using the right triangle, the other right triangle, this one and that one. Okay, this is the difference between the first coordinates, this is the difference between the y coordinates, and with this exactly the same idea, I get this fact that the distance between 2 points would be equal to square root of the differences between the first coordinates plus the differences between y coordinates plus the differences between z coordinates. Very good. As an example, distance between, for example, the point P1 with -1, 1, 0, and P2 with the coordinates 0, 4, and 10 is equal to square root of -1 minus 0 squared plus 1 minus 4 squared plus 0 minus 10 squared, which would be equal to square root of 1 squared plus -3 to the power of 2, which would be 9, plus 100, which would be 110. Okay, a useful formula which is gonna also use the distance would be equation of a sphere. So as a definition, I'm gonna remove that. So definition of a sphere. Oh, come on. Okay, so equation of sphere with radius r at the center. ABC is this, is x minus a squared plus y minus b squared plus z minus c squared equals to r squared. A, B, and C and R, they are just numbers, and X, Y, and Z, they are variables. Let me give you one example. Show that the equation represent, the given equation represent sphere. The equation is this: 3x squared plus 3y squared plus 3z squared equals to 10 plus 6y plus 12z. I'm gonna bring all the x's in one side, so I just have one x. I'm just gonna write this, and then I'm gonna bring all the y's. This is y on the other side, and I'm gonna factor out the 3. Okay, 2y actually. 2y, and then all the z's in one side, so plus 3. I'm gonna factor out the 3 minus 4z, and it's equal to the number 10. Okay, so as you see, I don't have any coefficient in here, so I'm gonna divide everything by 3. So I get x squared plus y squared minus 2y plus z squared minus 4z divided by 10 divided by 3. Okay, and so I need to make this one a perfect square, so I get y squared minus 2y. I'm gonna add a 1, I'm gonna subtract a 1, and in this part I have z squared minus 4z, and I'm gonna add a 4, I'm gonna subtract a 4 to make it a perfect square. So what do I have? I have x squared plus y minus 1 squared. I have a negative sign that I bring it on the other side, so it's equal to 10 over 3 plus 1. How about this part? This part, the first 3 terms would be z minus 2 squared. I have a negative 4 that I'm going to bring it on the other side. It would be plus 4. Okay, so if I simplify this part, the common denominator would be 3. I have 10 plus 3 plus 12, which would be 25. So I get 25 over 3 on this part. So it would be x squared plus y minus 1 squared plus z minus 2 squared equals to 25 over 3. It's a sphere. At the center, if you want to compare with this, at the center 0, 1, and 2 with radius square root of 25 over 3. Okay, so this is one application of the distance formula.